Well, what do we start with? I'm down with it. If we subtract 3x, then we divide by -2, what would we get, y'all?
1 equals 3 seconds, x equals 5 seconds.
Love it. And I'm going to go ahead and write that 5/2 or 5 seconds as 2.5 because it's going to help me graph it. Okay. Let's go graph it, actually. Let's go up 2.5. Boop. And then my slope is up 3 to the right 2 or down 3 to the left 2. Down 3 to the left 2. Then what do we need to do to graph the second one? I'm down with it. If we subtract x, we got -x minus 2. So I'm going to go down 2, and my slope is -1, which means go down and to the right or up and to the left. And with systems of equations, when you graph them, did we cross at a perfect point? It doesn't look like we did, does it? So are you like very confident to be like, I know exactly where these cross and where that solution is? It's going to be somewhere. I'm going to put mine in blue, like somewhere right there. So the graphing method's not very convenient to find that point of intersection if it's not perfect. And it's not always going to be perfect. So I kind of use this just to let you know, like, it's not always going to be great. I could find the exact answer by doing substitution or elimination, but why don't we just draw an arrow? Do we have an estimate? -1.8 is your estimate, and then what about the y? -0.2. I'm down with that, and I'm going to write estimate because I just want you to know the solution is just where they intersect. So again, graphing method's not very accurate unless it comes out perfectly. Okay, things that I don't really care about these words independent and dependent versus inconsistent. I don't care about it, but I just want you to know this one has how many solutions? One solution. This one has one solution because it crosses once. What would this is 2 lines, you guys. They're actually coinciding. They're the exact same line. How many solutions would these have? How many times do they intersect? Infinitely many solutions. Oh, look at that. These answers are right here. Infinitely many solutions. And if lines are parallel, how many times are they going to cross? None. So we'd say no solution. I'd say that's the most important thing that I'm looking for here. Okay, so what I want to do with that is let's practice this elimination. So again, graphing, we're finding out where they intersect. It says use the elimination method to solve this system. Elimination is when we need to eliminate a variable. Do we really want to graph this when we got 340 involved? Blech, that sounds terrible. Or 360. Elimination says, hey, go eliminate a variable. So could I eliminate my x's by multiplying one or both of them by some numbers? Could I eliminate my y's? You don't want to eliminate the constant. That's not going to help us. We got to eliminate a variable. Would you rather get rid of your x's? How about this? Give me an example about what we could multiply either function by to get rid of our x's. I'm not going to say we should. I just want you to know there are options. What could I multiply the top function by and then the bottom function by something else so that my x's would cancel out? Any ideas?
6 at the top. Or no, I'm sorry, 3 and then 5.
A 3 and then a 5. Don't write this down. Would that give me a 15x and a 15x? If I add those up, wouldn't I get 30x though?
So negative.
I would do one of them being negative because now I've got 15x and a negative 15x. Oh, I wouldn't write it because we got an easier way. Don't write this. This is just options. Could I have done this? Yeah, they're still opposite. And would they eliminate negative 15x, positive 15x is 0? We're good. I heard you say 6. Could I do 6 here? Sure, that would get me 30. What would I multiply this one by to eliminate my x? Negative 10 would get me a negative 30 and they'd cancel. Okay, but we're not going to write that down because that's not going to be the easiest way. What if I did, something with the y's? What could I multiply the y's by to eliminate a y? 2 to the top would get me how many y's? 4y. How many y's do I have on the bottom? Does 4 and negative 4 cancel out? Okay, I like it. Wait. What if I did this? What if I did 12 up here? What would that get me? 24 y's. What could I multiply this bottom by to eliminate my y's? 6. I'm just letting you know there are infinite options. Are some of them going to be a little less work than others? Sure. But the options are endless. So I'm with you. I think 2 on the top is going to be our best bet. So if I were you, I would go here and I'd say, all right, I'm going to multiply this first one by 2. And if I were you, here's how I'd show the work. I'm going to go ahead and distribute that 2, boom to boom. Everyone forgets to distribute it to that 340. And when I rewrite it, guys, I'm going to write it over here, and I'm going to line it up underneath this one. So 2 times 5x is going to get me 10x. 2 times 2y, positive 4y. 2 times 340, 680. I love it. You guys, then I'm going to say, I'm going to add these up. How many x's would I have now? 13x. How many y's? Boom. Because one's positive and one's negative 4y. We get to cancel those out. 680 plus 360. Okay, 1040. I dig it. Divide that by 13. You guys can use your calculators for this. What are we getting? 1040 divided by 13. Okay, if x is 80, you guys don't forget, when we're solving these systems, we're finding out where they intersect. We found out that they intersect when x is 80. I don't want to graph that, so I'm grateful for elimination. How would I go figure out what my y is? Yeah, plug 80 in for x. Doesn't matter if I want to plug 80 in to this x or to this x. Makes no difference. You can do whichever you want. Definitely grab a calculator. Definitely be typing this in. Which one do we want to go with? With the left or with the right equation? Left. I'm down with left because I got some space under there to do it. You know what I mean? But it doesn't matter. We're going to get the same answer. I'm going to plug in an 80 for x. So that's going to get me a 400 plus 2y equals 340. 2y equals negative 60. Is y equal negative 30? Okay. Question. What is my point of intersection? What is my solution? You know it, so add my solution thing. I'm going to say x comma y, 80, negative 30. That's my solution. Don't write down. Let's just do a little thought process. Gross. Do you want to work with decimals? Well, gross. I wouldn't. Could we get my y's to eliminate? What could we multiply by? There are infinite answers. 2 and 5? 5 would get me a 10. 2 would get me a negative 10. I like that. What else could we do? Ooh, 10 times 2 is 20. 4 times negative 5 is negative 20. I dig that. Could I do 50 and 20? I could. Do I really want to multiply by big numbers? No, but you could. We got calculators. You're allowed to. But I typically try to do the smallest numbers possible. So what are we going with here, people? 5. So I'm going to write it like this. I'm going to say I want a 5 here. I want a 2 here. Yes. Then I think it's really these arrows help you not forget to bring it to that 20. 5 times 1.5. 7.5 plus 10y equals 100. Then if I were you, when I distribute that 2, I'd write it right underneath. 2 times 2.5. 5x minus 10y equals. Beautiful. Then we're going to add them up, people. You add them up. 7.5x plus 5x. I see it, 12.5x. I love it. 10y plus negative 10y cancels. 100 minus 50. 50. Does 12.5 go into 50 nicely? Yeah. What do we get? Beautiful. If x is 4, where do you want to plug it in? First equation or second equation? There's no wrong answer. You want to go in the first? Okay. So Maddie's going to go boop, boop, boop. He's going to say 1.5 times 4 plus 2y equals 20. 1.5 4 times is 6. Y'all get a 7. Okay, what would be my solution then? What comma what? 4, 7. And we're going to say, yes, 4, 7. Because it goes x comma y. Substitution's helpful when you get a variable by itself and you can substitute its value in. It's like when Jack had to get subbed out of the soccer game last night, someone took its spot, right? Okay. I don't know if you got subbed out. Did you get subbed out?
Yeah.
Garrus, ready? Garrus, you are y. That means that you are right here. But Cece is also y. Garrus, you get tired.
Yeah.
Can Cece, who is 3x minus 8, take your spot? Yeah. When Garrus gets subbed out, does Garrus stay on the field? Like on the soccer field? No, he gets subbed out to the bench, right? So when you plug in Cece for Garrus, this y is no longer here. That y is going to be replaced with the 3x minus 8. Some people want to put like y times 3x minus 8. No. Garrus is off the field. Cece's in. So you guys, couldn't we say we got 2x plus, what are we going to say now? Thanks, Steph. 3x minus 8 got subbed out equals 22. What is 2x plus 3x? 5x. I'm going to throw that 8 over all, throw that 8 over all in one step. 5x is 30. X is 6. Garrus, you're 6. What is your soccer number?
8.
Gosh, I would have loved for it to have been 6. That would have been sweet. If x is 6, where can I plug that in to figure out what y is?
In the y equation.
I could do that one, or I could do that one, right? I'm with you, Thomas, though. This one's going to be easier because the y is already by itself, right? But you could put it into either, and let's solve for y. So we got y equals 3 times 6 minus 8. What do we got for y? CC is 10. What's Christian's number?
No idea.
Not 10?
I don't think so.
Okay. Again, would have been great. Okay. So you guys, substitution is bomb when a variable is already by itself. Would you want to do substitution on this problem? Do you want to get an x by itself? I'd have to subtract 2y and then divide everything by 1.5. Gross. If I wanted to get y by itself here, subtract 1.5 and divide by 2. Gross. So these equations lend each other to substitution when the x to the y has a coefficient of 1. That's going to make our lives a lot easier. Let's do this one here. Do you want to get this x by itself, that y by itself, second x or second y by itself? Second x, I dig it. Let's get this x by itself. How would we do that? Add my y. And I like that you got the x by itself because it doesn't always have to be a y by itself. Can we go plug in y plus 2 for this x? Boop. Sure can. What do I need after that 2? Yeah, we need some parentheses, guys. We need some parentheses with that y plus 2 because we're going to have to distribute that 2 to them. We're going to multiply. So we got 2y plus 4 plus 3y equals 8. Okay, you guys, how many y's do I have here? 5 y's equal 4. Oh, yeah, I heard it. Then y is 4/5. Am I going to get that by doing a graphing method? Certainly not. I wouldn't know if that was that accurate. Okay, which one do you want to plug 4/5 into? My first equation or my second equation? Okay, again, we've got the same answer, but I agree it's going to be a little less work over here. X minus 4/5 equals 2. When I add 4/5, 2 plus 4/5, let's get some common denominators. So I could say 2 is the same as 10/5 plus 4/5 would get me 14/5, which you said is 2.8. Yep, agreed. Either of those is great, but I like that this one, I just don't want you to use a calculator is what I want. You know what I'm saying? I want us practicing these skills. So if I were you, I'd be ending at 14/5.
Like I write that.
My solution would then be X comma Y. So I'd say 14/5, 4/5 for a leased car. Do we want to? We've got to lease a car for 2 years, get us through high school, if you will. Dealership says they'll lease her a car that she has chosen for $326 a month with only $200 down. Maybe that's potentially reasonable for you guys. Whatever. What if we paid $1,600 down? That's a lot more down, but we're only paying $226 a month then. What's the break-even point? I.e., where do those intersect to figure out which is a better option for her if she's doing a 2-year lease? So what's one equation going to be? Y equals, how much does she spend in a month for this black equation? $326 every month. So that's going to be my slope. Very good, Steph. Plus, how much is she putting down? It's going to be plus 200. This is going to say how much she's paying. If you want to make them both negative, you could, meaning she's going to be in that debt, but I think it's okay making them both positive. What about the other one? $226 a month with how much down? Do you guys understand what putting money down means? It's like what you have to bring to the table that day to walk away with the car that day. So this option, you only have to bring $200 cash, which maybe you guys have in your bank account then. And then a month later, they're going to start billing you $326 every month. So this one I think seems doable. This one, I don't know if you've got $1,600 cash in your savings account right now to give them that day to take the car away. But then they're only going to bill you $226 a month. So how would we figure out where those intersect? Where are we spending the same amount of money? Substitution or elimination here? What would you rather do? I feel like this would be a really easy one for substitution because they're already equal to, both of them are equal to Y. So we could just set them equal to each other. So we could say 226x plus 1,600 equals 326x plus 200. Let's go solve for x. I'm going to subtract 226x. What'd you get for x? 14. And what's that referring to? She's paying $326 per month, right? $226 per month. So in 14 months, can we figure out how much she will have paid on each loan? Can I just substitute that in? What is, by plugging in 14 in for x in either equation, you guys, 326 times 14 plus 200 is going to get me, 4,700. Does that sound right? Okay, so it's going to cost in 14 months, you will have spent $4,764 on this car. She wants a 2-year lease. At 14 months, no matter which option you go with, you will have paid $4,764. Her lease is 2 years.
How would you answer the question?
Well, let's think about it. If it's a 2-year lease, how many months is that? 24 months. If at 14 months, no matter which option I go, I've spent $4,700 for the next 10 months, would you rather pay $326 a month or $226 a month? Wouldn't you want to save $100 a month? So if it's a 2-year lease, we want the $226 per month option for the 2-year lease.
How did you find that, like, you're going to be paying that much for 14?
Good question. We just plugged in 14 for X. Yep. Now, what if it was only a 1-year lease? Which one do you think I'd want to do? Right? Because at 14 months, we're paying this much. I want to put a little less down. So if I did 326 times 12, so because for 1 month, for 1 year, the 326 a month would have cost me 4112, and the 226 times 1 year plus a bigger down payment, 1,600, is going to cost me 43. It's going to cost me 200 extra bucks. So is this real world? For sure. And I'll never forget